we have a path, something like this. Call it M, H, and P. What do they tell you? Oh, and by the way, and also, sorry, let me give you a... They tell you what? Which path?
Isn't it from N to P?
Yep, that's correct. I had to put N in there so you could say that. N to P is 1,500 feet. That's correct. What else did I tell you? M to H is 500? No, M to N. Yeah, sorry. N to H is 500. Correct? And they also labeled this as theta, right? Great. Calculate the time t if you walk 1,500 feet along the paved path and 500 feet on the sand. So for A, time is going to be, someone tell me what I need to do. 500 divided by 100 plus 300. So if you do those distances, you end up with 10 minutes. Okay, that's great. So B, calculate time t if you walk in the sand directly towards the ocean for 500 feet and then turn left and walk along the beach for 500 feet. So essentially, you're spending how much on the sand? 2,000 feet, 100% of your time, exactly. Divided by? So if you go out to the ocean and go left, which could be a common path, you want to go see the ocean and walk along the beach, which also adds in the added complication of maybe the sand is easier to walk on close to the ocean. We're not thinking about that. Nothing has a width, it's just perfect sand. Careful. 2, 0 minutes. Good. C. Express the time t to get from the parking lot to the beach house as a function of the angle theta shown in the illustration. Now this is by far the entire core of the question. If you don't do this one, you can't do the rest. This is by far the hardest part. So what two distances do you need first?
From M to P.
Yeah, you need M to P and H to M. Exactly. Which one's easier to find, or which one do you want to find first?
M to P.
Let's do HM first. Let's do HM first. Now, what's one way you can find, what trig function could you use? And please don't open your mail. Thank you. Yes? Sine, yeah. Sine of theta is equal to what? HM opposite, so HN over, and what is HN? So, I should have picked different sounding letters, sorry about that. So what do we now know? We now know that HM is equal to what? 500 over what? Sine theta. So we have the first part, we have HM. Now what do we need? MP. Now what's the distance from N to P? So what's one way to say PM? 1,500 take away what? NM. Let's use the letters that are up there. So if we found NM in terms of theta, we'd be done. What trig function could we use to find NM? Sorry, what trig function could we use to find NM? In this triangle, we know that's 500. Tangent. Tangent theta is equal to what? Nope. 500 over what? NM. Correct. So what does NM equal? Tan theta, exactly. So where can we take that now? Where can we plug that in? Right there. So now what do we have? PM equals 1,500 minus 500 over tan theta. Excellent. So do we now have both distances in terms of just theta? Yeah. Total time traveled is equal to distance on sand divided by what? Plus distance on pavement over what? Distance on sand divided by 100 and distance on pavement divided by 300. Do we have both of those distances? Yeah, so the total time in terms of theta is going to be, t in terms of theta is going to be, what's our distance on sand? Do you remember? It was, where, did I write it down somewhere? Right there, sorry, thank you. 500 divided by sine theta. So 500 divided by sine theta all over what? Plus 1500 minus 500 over tan theta all over. Can we clean that up a little bit just to make it a little prettier? Yeah, we sure can. What does this turn into? T of theta is equal to 5 over sine theta plus 5 minus 5 over. What could you factor out? You can factor out a 5. You can write it as cotangent and cosecant. Why, in this case, why do we not really want to do that? What's next in this question? Yeah, you have to use the next formula. What do you have to use? What do you have to use in order to solve the next few problems? Yeah, and when you type things into your calculator, what are you going to have to write them in terms of? Sine and tangent, not cosecant, right? But you could, if you wanted to, simplify this. It would be 5 times cosecant theta plus 1 minus 1/3 cotangent theta. Is that the same thing? Now that looks a little better. Here's the thing, though. You now have to look at what the next question asks. D, calculate the time t if you walk directly from the parking lot to the house. They want you to use this formula. You don't have to, but they want you to, obviously. Now, to use this formula and use your calculator, you're going to have to type it in terms of tangent and sine. Is there directly a secant or a cotangent button on your calculator? No, there isn't. So in this case, there's 2 ways to answer the next question, which was D. The next question, D, asks, so if you go straight there, so this is the triangle you're dealing with. You have 1500 here, and you have... Now, if you didn't use this formula, what could you do? What? Well, no, if we didn't use the formula, if we didn't use theta, and we just want to find the time, what can we use? Yeah, use the Pythagorean theorem to find this distance, right? So we know that D is going to be equal to 500 squared plus square root. I'm just doing that. Yeah, right? We can do that. And then if we want the time, it's going to be divided by 100. So if you do that out on your calculator, 500 squared plus 1500 squared divided by, oh, not divided by, what do we have to do to that? Well, there it is. Oh, and then divided by 100. Thank you. Almost did it, right? Almost. So we have this right here. So what does that say? How long does it take? Almost 16 minutes. Now, is that a realistic answer? Yeah, an unrealistic answer would be 700 minutes or -5 minutes. In the realm, what was the first time? 10 minutes, right? If you went down and over. This one is if you go straight on the sand, it's 15 minutes. If you went all the way over on the sand and down, it was 20 minutes, right? So is this in between those two things? Okay. Let's use this formula, though. If we want to use this formula right here, we need to find out what theta is. How do we figure out what theta is? Well, they give you that hint. What is it? And they don't really need that hint. Tangent theta is equal to, which is 1/3, right? So if you want theta, what is theta equal to? Tan inverse of 1/3. Now here's the thing. If you're going to use your calculator, you just need to be careful. Let's type this in as a function on your calculator. Oh, look what I've already have there. Isn't that nice? I've already typed it into my calculator. And what do we need to evaluate that at? Tan inverse of 1/3. The angle we want is tan inverse of 1/3. So we can do that a couple ways. So what is that angle? Let's see if it actually works. Tan inverse of 1 divided by 3. Does that make sense? Does 18 degrees sound about right? Yeah, realistically, it's an acute angle, and that matches. That's nice. So we want to plug that into our formula. What function? We entered it in as y1, right? So what can we do? How do I get y1 on my calculator? Where do I go? Vars, y vars, function y1. And you know what you can do here? You can actually do the second tan inverse of. You can do that if you want to. And look what you get. 15 point. Does that match exactly what we got?
Yes.
It does! It does in fact match. Look, does it match perfectly?
Yes.
Same. Yay! What's another way you can evaluate this? Well, if you wanted to graph this, you have to be very careful. First of all, it asks you, what would theta be if you walked, so up here, this is theta right here. What happens if you moved m all the way over to n? So let's say you walked straight from the house to the pavement and walked over. What would theta be if m was moved all the way over to n? 90, right? That's the biggest angle value, because if you go any further than that, does it make any sense to go here and then back? You could, but we're limiting it to straight down and over, so it's 90. What's the smallest angle value? Well, we just figured it out. What is it? Yeah, the smallest angle value would happen right here, right? And what was that? We just figured that out. What is it? 18, tan inverse of 1/3, 18.4 something, right? So when we graph this, it's really important that we pick the proper domain and range, because if we don't pick the proper domain and range, what happens to our graph? It gets really weird, or you might not even see it, right? So what's the smallest x-min we want to do? Second tan inverse of what? 1/3. What's our max? What should we do for our max? 90 degrees. What about for our output? We got 10 minutes, 20 minutes, 15 minutes. So I chose 0 to 30. Could we maybe make it a little narrower? You can make it a little more narrow, but is it okay if it's a little bit wider than you need to be? Like, for example, I'm going to make this actually 100 degrees, just so we have a little bit of extra there. So let's graph this and see what it looks like. It goes down, it goes down, it goes down, and then it goes up, up. It should go. Oh, look, it does go up. That's good. It means there's a minimum somewhere in there. Now, if you have graphed a function and you want to evaluate it, what function should you use in order to evaluate the function you have graphed? Do you see calc up there? Right here? You see where the cursor's moving? So second trace, you see value? You get to enter the x value in, and it pops out the... So what should we enter in? Second tan inverse of? There it is. So did we just do it 3 different ways? Yeah. So you can use a graph. But what do we now know? But look at this. That point is right here. Same. What happens to the overall time as the angle gets bigger? What happens to time as the angle gets bigger? Is the angle x or y here? Yeah, so as the angle gets bigger, y gets smaller. Y is what? Time traveled, right? So in this case, as the angle gets bigger, what happens to time? It goes down, and then what happens to it? So if you want to minimize time here, oh, look what it asks you for. Let's skip E for a second. We can calculate T if you walk 1,000 feet. We should do it, actually. It's asking you for another data point. It's asking you for this. If this is 1,000 right here, and it tells you that this is 500, oh, it tells you that's 5. No, it doesn't even tell you that's 500. It's not. It tells you that's 1,000. You know that the whole distance, what's the height here from here to here? 500. So what's the base of that dotted triangle? It is 500 because the whole thing is 1,500. So what's the hypotenuse of a 500 triangle? 500 root 2. Yeah. So what's the time traveled here? 500 root 2 divided by 100 plus by 300. Not 3,000. 300. If you do that out on your calculator, oh, quit. Divided by 300 plus 500 second root 2. What are we dividing that by? What are we dividing that by? 100? Not 1,000. So that means it's 10 minutes. So it means if you do 45 degrees, if you did 45 degrees, what do I mean by 45 degrees? I meant this being 45 degrees right here. You end up with a little bit longer than 10 minutes. Well, it was 10 minutes if you went straight down and over, right? So if you went straight down and over, it was 10 minutes. If you went over on the sand, just the sand, all the way over and down, it was 20 minutes. If you went directly across, it was like 16. So somewhere in between, it should be less than. There should be a minimum in there. What do you have to use in order to find that minimum? You're going to have to use the graph. And what function should you use? Should use the minimum, yeah. So when you use the minimum, you have to be careful. Just left bound and... Take a look at this. So when we went straight down and over, that got us to the pavement, which is the fast traveling the fastest. But that was a longer distance traveled than if you did this. But if you do that diagonal, that's the slowest path possible. Like your rate is slowest. So somewhere in between, there might be a minimum. Are you always guaranteed to have a minimum somewhere in between? Not really. If the pavement became too much faster, let's say it was 400 feet per minute, I can pretty much guarantee that the best path would be get down and over. I mean, think about it. If you go down and over, it's 10 minutes. If you go 70 degrees, it's just 9.7. So basically, how much time do you save? How much time? What? Yeah, like 20, like 50. It's a quarter, a little bit more, like 20 seconds about, right? It'd be exactly, you would save exactly, let's do this on our calculator here. It saved it as y. You see that right there? Alpha, yeah, go ahead.
If you trip and fall, then you just lose those 20 seconds anyway.
Exactly. So you actually save, 60 minus that, sorry. You save a little over 17 seconds. You're minimizing time travel this way. But what do you have to use? You have to use your calculator. Now, by this point, the last question is pretty obvious. It asks, why is tan theta equal 1/3 gives you the smallest angle that is possible? Well, assuming he doesn't want to overshoot the house, what is the angle going to be? Tan inverse of 1/3. This came up in the last class. So why doesn't he want to? Well, are there a lot of givens you have to assume about this problem? Aliens don't give him a teleporter. He doesn't decide to go around the world before going to that. He doesn't go this way. He doesn't go off in the opposite direction. Are there a lot of givens that you have to make sure that you give yourself? Yeah, absolutely. Sometimes it is advantageous to define something by what it's not. A whole lot of the time, you just define something by the common standards. Okay. It's about 25. How many triangles? Law of cosines and how many triangles are you dealing with? One triangle. Is it nice when there's only one? So you have a triangle A, B, C, and what did they tell you? 50, 70, and 70. What are you trying to find? So you know that AC squared is equal to 50 squared plus minus 2 times 50 times 70 times cosine of... Can someone tell me what AC is, rate to 3 decimal places? Goss. How many people agree with that? Sounds about right. 3, because the AP test demands 3. If you don't do 3, it's wrong. Again, what's nice about 26? What? Yeah, one triangle, exactly. Things fall in directly, so they give you that, and they tell you that it's, what, 50 degrees? So therefore, that's 130 degrees. So what do they ask you for first? The distance from Fort Myers to where? Orlando, exactly. So it's the same thing, right? Can someone tell me what the distance is? Yep. People agree with that? Now it asks you next, what return angle? So you have to think about this. You know that the plane is heading in that direction, right? So what angle are they asking for? This. So if this is F, O, and, I don't know, J, what angle are you looking for here? 180 minus what? What angle? J, O, F, right? Looking for 180 minus that. So now that we have 227.560, what rule can we use now? What law? Yeah, so you know that sine of 130 over 227.56 is equal to the sine of JOF over what? 150, yeah. Does anybody have angle JOF? What is it? No, JOF. JOF is what? I'm sorry, yeah. What is it? Who agrees with that? So therefore, what's our turning angle going to be? Yes, 140 what? Does that make sense, everybody? Once you use the law of cosines, you will automatically be able to use the law of sines because you have found the opposite distance to an angle. Yay!